Welcome to Digital Class students. Today is the second session of chapter sets, and today I will discuss some of the types of the sets. Already in the previous class, I have explained what is a set, the introduction I have given, and with examples I have illustrated also. Now we'll move on to the types of sets. Look at this place. This is a city. What you are observing? You are observing some buildings, some roads, playground, some plants, cars, everything. These are all located within the city limits. For example, if you take Hyderabad, so the buildings, plants, roads, playground, and everything will be located inside the city itself, isn't it? Like this is a school building. The school building consists of some tanks, some stage, and this is a school building, and you can observe a car, a tree, and these are the classrooms, and this is an office room. These are all located within the compound wall itself, isn't it? Like this, when we take, this is a compound wall which is in the form of a rectangle, and these are the classrooms. This is class 6, class 7, class 8, 9, 10th class, and this is the principal room, and this is a library, and this is a laboratory, and the school has one playground also. When you observe this, all these classrooms are located within the compound wall premises itself. So when you look at the picture, see, all this comes under, you can say this is a school. For example, this is ZPHS Srirangavaram. The class in school ZPHS Srirangavaram means you can say 6th, 7th, 8th, 9th and 10th classes. So these are all located within the school premises. So you can say the school compound wall is an universal set, because all these are all small sets which are located within the school premises. So the definition of a universal set is nothing but this is the set containing all objects or elements and of which all other sets are subsets. So these sets are subset of this big rectangle. So the rectangle is nothing but the universal set, and the universal set is denoted with an italic symbol, that is mu. This is a universal set. Look at this. This is a universal set. Okay. Next. So I have explained regarding this. This is a compound wall, and the compound wall, within the compound wall, you can see classrooms, playground, a library, a laboratory, principal room, everything within the compound wall itself. So what is there within the classroom? What you'll observe? You can observe benches, chairs, students, which they sit inside the classroom and they listen the classes. So these are the students. These students are sitting inside the classroom. So you can say that these students are the subset of the class 6. So these students are located inside the classroom. You can say these students are subset of the classroom, that is class 6, and the class 6 itself is a subset. The class 6 is located inside the school premises, that is inside the compound wall. So you can say the class is a subset of the universal set. So the subset is denoted like this, like an alphabet C. Like this we will denote. Therefore, I'll give the definition of the subset. The set of all elements are contained in another set. So subset is nothing but the set of all elements are contained in another set. Here, for example, the class 6, class 7, 8, 9, 10, all these classrooms are located inside the universal set. You can say these classes are the subset of the universal set. And when you observe the students, these students are inside the classroom, they are listening the class. So you can say these students are the subset of this class, and the class itself is a subset of this universal set. Therefore, every set is a subset of itself, and empty set is a subset of every set. Therefore, next, let us know what is an empty set. See, can you write natural numbers less than 1? Can you write? Is it possible? No. This is not possible. And can you write whole numbers less than 0? Is it possible again? No. This is also not possible. So how you will write set for this? This set is nothing but empty set. You have to show in a flower bracket like this, and you have to show nothing, no elements inside the set. This is nothing but you can say a null set also. So a set which does not contain any elements, not even a single element, you can say that set is a empty set or a null set. This is an empty set? Think, children. Is this an empty set? No. Why? 0. Of course, 0 interprets nothing. But 0 is one of the element. So at least one element is there inside the flower bracket, and you can say that this is a singleton set. And you cannot say, you cannot predict like this is an empty set. Now, look at the roster form here I have given. The set A are the students Ashok, Amar and Anthony. Set B also Amar, Anthony, Ashok. Same students, but the students are shuffled. And look at the set C. In this, again the students' names are shuffled. Anthony, Ashok, Amar. Could you notice anything? Yes. Set A is a subset of set B, and set B is again a subset of set C, and you can say set A is a subset of set C. So the elements which are there in set A, those elements are there in set C, and those elements are there in set B also. But what happened? Just the names were shuffled. The position of the elements are shuffled, that's all. So you can say that A is equal to B and B is equal to C, therefore A is equal to C. So these type of sets, we can say they are equal sets. So two or more sets having same elements. So the elements are same, but the elements were shuffled, that's all. These type of sets are equal sets. Now, look at these sets. Here set A containing elements Ashok, Amar, Anthony. Set B contains elements like 1, 5 and 3. Set C, these are the cricketers, Sachin, Kohli and Dravid. So what is the difference you note in the previous slide and this slide? Is there any difference? Yes. Before that, I'll tell you what is the cardinal number. Cardinal number is the number of elements which are there inside the set. See here, in set A, there are 3 elements, that is Ashok, Amar, Anthony. 3 elements. In set B, also 3 elements, 1, 5 and 3. In set C, how many elements are there? Here also Sachin, Kohli and Dravid. 3 elements are there. So, if the cardinal number is same, like number of elements in set A, 3, number of elements in set B, 3, number of elements in set C, also 3. If the cardinal number is same, you can say these sets are equivalent sets. Do you notice what is the difference between an equal set and an equivalent sets? Yes, equal sets means the elements should be same, but in equivalent set, the cardinal number should be same, whatever the elements may be. The equivalent sets, 2 or more sets having same cardinal number. Therefore, you can say these are equivalent sets. Thank you, children. This is all about some of the types of sets which are useful for your 10th class. So in the next session, I will tell like Venn diagrams and more important questions which you'll get in the final examination. So keep watching. Thank you for listening.